How can anyone compute sine? I mean, nowadays people use computers or calculators, but by what mysterious force are these computational devices able to perform these computations? How does the machine know what sine of 1 is equal to? So that's a good question. How do we compute sine of 1 radian? One way is to use a little bit of calculus. So what does calculus tell us? So let's set f of x equals sine x, then the derivative of f is cosine x, the value of f at 0 is 0, sine 0 is 0, and the value of the derivative at 0 is 1, because cosine 0 is 1. Now I can use the derivative to approximate the function's value. The function's value near 0 is the function's value at 0 plus how much I wiggle the input by times the ratio of output change to input change, the derivative at 0. Well, given this, in our specific case, the value of the function 0 and the derivative at 0 is 1, and that means the function's value at h, for h very small, is about h. That means that sine of a very small angle is very close to that same value. Let's actually use some numbers. So very concretely, sine of, say, 1/32 is really close to 1/32. Now, in addition to this, we've also got a double angle formula. The double angle formula for sine says that sine of 2x is 2 times sine x times cosine x. You can derive this formula from the angle sum formula for sine. Sine of x plus x gives you this. Alright, another way to rewrite that double angle formula is to write it entirely in terms of sine. Cosine is the square root of 1 minus sine squared x. Well, as long as the cosine is positive, this is true. So if I'm working with a value of x for which cosine is positive, then sine of 2x is 2 times sine x times the square root of 1 minus sine squared x. We can put these pieces together. Well, here's what we do. I know that sine of 1/32 is very close to 1/32 because 1/32 is close to 0, and sine of a number close to 0 is about that same number. Then I can use this double angle formula entirely in terms of sine to get an approximate value for sine of 1/16 by using my approximate value for sine of 1/32. Then I can use this double angle formula again to get an approximate value for sine of 1/8, and again to get an approximate value for sine of 1/4, and again to get an approximate value for sine of 1/2, and then again to get an approximate value of sine of 1, which is really quite close to the actual value of sine of 1. So what happened? Calculus told us that sine of a small number is close to that same small number. The double angle formula let us transport that bit of information around 0 to points much further away, all the way to approximate sine of 1.